Hey everyone, Mike here with the Sysadmin School, and in this video I'm going to show you some of the different storage and storage provisioning options that we have within Windows Server 2016. Now, starting with Windows Server 2012, Microsoft made some great changes to how we can effectively use and provision storage within our physical server. So enough of that, let's get right into it. So we're here on our brand new Windows Server 2016 server, and I'll show you, just if I minimize this here, you can see that it even has the default name that you get when you first build a server, and we have the default, well, we have an IP address that I gave it. I've gone ahead and given an IP address. It's got 4 gigs of memory, and you can see we're only seeing one volume here, and that's the C drive for the operating system, which is about 120 gig. Now, we actually have 5 total drives attached to this server. So if we go into Server Manager here, and if you watched the storage video on Windows Server 2012 R2, it's very similar to this. It's almost the exact same, but I wanted to make sure that I completely covered everything. So if we come in here, we're in Server Manager, and we go to File and Storage Services, you can see that our server name, and if we go to disks, we can see all of our disks. So we have our disk 0, which is 120 gigs, and it's got the master boot record on it, and it's online. You can notice too that the other 4 disks we have are all offline. Now if we come down here and look at our volumes, really the only volume we have, you can kind of ignore this one, is our C drive volume. So with previous versions of Windows prior to Windows Server 2012, you could mix these drives together, but you could really do it only into a RAID array, and it could get kind of complicated, and it wasn't overly easy to do within the operating system. Most of the time, if you wanted to do this, you were going to do it within the BIOS, or you needed to actually have like a RAID chip on your computer or your server to do this. With Windows Server 2012 and beyond, and we're looking at Server 2016 here, you don't need that. They actually built a lot of this in. So let's go ahead and go through the process of setting this up. The first thing we want to do is create a storage pool. So we'll come over here to Storage Pools, and what we see is we have what's called the Primordial Storage Pool. And you can see when we have this selected, all the physical disks that are unassigned, which are the 4 additional disks we have, not the operating system disk, are in this primordial pool. So the primordial pool is a default pool, basically, that any unallocated disks are automatically put in. We're going to create our own storage pool by right-clicking and choosing New Storage Pool. Now it's going to take us through a pretty easy wizard to do. We'll go through, we'll give it a storage name. We'll call this Mass Storage. We're going to select where we want to get the disks from, which is our server here. And now we have the option of choosing whichever disks we want. So I'm going to go ahead and just choose the first 3. And you can see, we can see the size, the bus type, the fact that they're a virtual disk because we're using VMware in this case, and these are just virtual disks that I've attached, but they simulate real disks. Now we have the allocation section. Now typically we want to just leave this as automatic, but one of the options in here is hot spare. So what a hot spare does, if you're not aware, is a hot spare basically just sits there and isn't really used all that much until a drive fails. Once a drive fails, the hot spare will kick in, and it will start to be used. So that way you build in more redundancy. We're not going to even bother with that at the moment. We're just going to go ahead and select the allocation as automatic. And then you can see with the 3 40 gig drives selected, that's going to give us a total capacity of 120 gigs. So we'll click Next. And it's going to confirm everything that we've selected, and we'll click Create. And you'll see here there's a reason. You're probably wondering why I didn't do all disks. You'll see here shortly why. So now that we've created this, we can click Close, and we can see our mass storage pool and the 3 disks that are part of that. Now we still have our primordial pool because we still have 1 disk that's unallocated. But if we look at our mass storage pool, we can see the capacity, the free space, and how much of it has actually been allocated, which is awesome. So let's go ahead and allocate some space to this, or to a drive. So we right-click on the storage pool itself and create a new virtual disk. So now this is basically creating like another disk using the pooled storage that we have. So we'll just click the storage pool we want, and then we get to go through another wizard. So we'll call this light storage. and then we'll click next. Now, enclosure awareness, this is actually a new feature within Windows Server 2016, and basically it helps protect your data if, say, an entire enclosure fails by copying your storage to a separate storage enclosure or a JBOD, which stands for just a bunch of disks. We're not going to worry about that here, so we'll just leave this unchecked and we'll click next. And now we get to choose what type of storage we want to do. We can do simple, where the data is striped across all of our disks. This maximizes, as you can read here, the capacity and increases the throughput, because now we have the collective of all the disks that we're using in our pool to improve our performance as well as maximize our storage capacity. The problem here is you're not protected by a disk failure. So if you have a disk failure in this pool and you're using a simple storage layout here, anything on that virtual disk is going to be lost if you lost a drive in your storage pool. Mirror is going to stripe data across the physical disks and making sure you have at least 2 copies of your data. This is the best way to go in order to keep resiliency and if you have a disk fail, not have it actually lose all your data. The problem is with this one is you lose a lot of your capacity. So if you, say, have 20 gigs of data, you're going to be using 40 gigs because there's 2 copies of that data. Parity is kind of in the middle. It basically stripes your data across all the disks for better performance. It also stripes parity information, so information about the data on those disks also gets striped across all the disks. So this increases resiliency. So if you lose a single drive, you're not going to lose all your data. But similar to Mirror, not as bad, it's going to give you less overall capacity. Since we're just playing here, we're going to go ahead and click Simple, and we're going to go Next. And now we get to choose our provisioning type. Now there's 2 different provisioning types, as you can see. There's thin and there's fixed. Thin provisioning basically says I'm going to allocate this much storage space for your drive. So if we created a 20 gig drive, thin will say, okay, the operating system knows this drive is 20 gigs. However, the space actually being used is only utilized when you then write stuff to that disk. And we'll see a little better indication of that here in a second. Fixed is where when I say I want a 20 gig drive, it allocates a 20 gig drive. It'll allocate a 20 gig block out of our storage pool that can't be used for anything else. So that's what fixed is. And fixed has a little less overhead than thin provisioning, which is one of the reasons you may want to use it. If you're using something like a SQL Server, something with heavy writes, you may want to use fixed over thin provisioning. For us, we're going to go ahead and use thin provisioning and click Next. Now we can specify the size of our virtual disk, and we're going to go ahead and just choose 10 gig. And now we get our confirmation window that we typically get with these wizards. So we'll click Create here to create our new virtual disk. It's going to go through and get all the information. And what you'll notice down here at the bottom is it already has checked the create a volume when this wizard closes. And now that we've created the virtual disk, we aren't going to really see it or do much with it unless we create a volume on that disk. So that's why they check this by default. So let's go ahead and do that. So we'll go ahead, now we're in the new volume wizard. So we'll click Next. We choose our server, and then we can see this is the virtual disk that we just created. So we'll click that guy and we'll choose Next. And then we'll give him the maximum capacity that we want because we want to do that. So we want to give him 10.5 gig. Then we choose a drive letter that we want. E is fine. And now we get to choose our file system type and a volume label for this volume. So I'm just going to label this light storage. And Next. Again, back through all the confirmation. We'll click Create. And it's going to run through everything, and the piece that takes the longest here is actually formatting the volume. So we're going to let it format, which actually went really quickly in this case, and now we click Close. And what we can see now is under our virtual disks, we have our light storage with the simple layout, thinly provisioned, and the volume is E. Now, the cool thing is if we actually look up here at capacity of our mass storage pool, we have a capacity of 118 gig. However, free space, we have 114. But we allocated 10 gig to our virtual disk. So shouldn't that be 108, not 114? Well, that's the point of the thin disks, is it's only going to actually use up space in that storage pool when you write something to that disk. So just to give you another view of it, if we open up File Explorer here, we can see now that we have our light storage drive. Now, I made this drive too small, and I'm just realizing that I don't want this drive to be that small. So let's extend this drive. So how do we do that? Pretty simple. We simply go to our virtual disks here, and we can right-click and do Extend Virtual Disk. We can see what our current size is, and we can tell what we want to have next. So I actually want this to be, let's make it 30 gig. Perfect. So click OK. And now you can see that this is bumped up to 30 gig. Well, that's great and all, but if we look here, our drive is still only 10.4 gig. So what do we do here? So now we have to actually increase the volume. So if we come up here to volumes, we can see our E drive here. We can right click and same thing, extend volume. And now we see what the current size is, and we see the max size that reflects the virtual disk that we extended. So we'll make this 30 gig. Click OK. And now you can see we have a 30 gig drive with 29.9 gigs free. And if we refresh here, same thing. So this is great. Now, let's take it one step further. And I have a storage pool, and let's say my storage pool is running out of space. It clearly is not, but let's imagine that my storage pool is running out of space, and I bought some brand new disks to go in that storage pool. So I take the server down, or if they're hot swappable, I add the drive in there, and I rescan my storage. And what I would see in that case, we already see it because I already had the drive there, is we would see the primordial pool kick back in, and we'd see whatever disks we added. So I still have this 40 gig that I didn't allocate. So let's go ahead and allocate that. Let's give our mass storage pool another 40 gigs. And we simply do this by right-clicking on the storage pool we want to add the disk to and select Add Physical Disk. Now it's only going to show us, obviously, the disks that we have available. So this disk is available. It's the only one we have left. So I'm going to select that guy, and we'll click OK. It's going to run through and add the disk to it, and you can see now that we've automatically updated our capacity to 157 gigs. So it's now added that additional 40 gig drive in. So this is really cool now because we buy a server that just has slots in it. We can start with a low one, and as we progress, we can then just add drives. So we can add terabyte drives, we can add whatever drive we want, we can just add them in there, and then we can just extend our storage pool this way. And it makes it great and very flexible for adding more storage to your server and to your network. If you liked this video or it helped you out at all, I would love for you to check out my site, thesysadminschool.com, where you'll find some great information on learning to become a systems administrator or help your career as a systems administrator. Now, I'd love to hear what you think, so please leave a comment or feel free if you want to get more information like this to join my mailing list. Thanks for watching, and I hope to see you guys soon.